Alright, I'm just gonna explain this for babies, alright? So here is what I'm trying to say. So imagine two right triangles. As you can see here, there's a one right triangle over here and another over here. Now, the first triangle is named triangle ACB. It can also be ABC, it doesn't matter. So we have triangle ACB and triangle DCB. And in this case, both triangles are congruent. This is the given here. DCB and ABC is congruent to DBC. Here, this is our given right here. Take note. So when we merge these two triangles together, we get, I forgot the, when you merge these two triangles together, we get this. It's just a regular triangle. We have A, B, C, and D. So, what if we want to find ACD? How do we get ACD? Now, to get ACD, we must add both angles according to ACD. So, basically, just add the adjacent angles. That's right. You gotta, merge the adjacent angles into one and you get the triangle. Alright? So, the adjacent angle here is the adjacent angles here are ACB and DCB. As you can see here, we have A, C, B, and D. Oh, that's not a B at all. B and D. So as you can see, we have angle ACB and angle DCB. But why can't we do ABC and DBC? Because we're looking for ACD. So if we were, trying to add both ABC and DBC, this is how it's gonna look like. A, B, C, and D. As you can see, it's not like, it's not connected. So we cannot find ACD that way, alright? So we're just gonna do it this way. ACB and DCB. So like I said, to get angle ACD here, let me just write it down so we don't get confused. To get angle ACD, we must add both adjacent angles. And both of these adjacent angles are, of course, angle ACB. I'm so bad at writing B's. And, of course, angle DCB. Now, in this case, as you can see here, both angles ACB and DCB are congruent. So let's write that down. Angle ACB is congruent to angle DCB. Now, when two triangles are congruent, that means they're same in both size, shape, measurement, everything. They're the same. They're congruent. So since we have that information, we could just replace DCB with ACB because ACB and DCB, they're just the same in this example. So we could just replace it. Angle ACD is equal to angle ACB plus angle ACB again. As you can see, I replaced DCB with ACB because they're the same. Alright? Now, we can still simplify this equation more. So, you know how we have two same terms here? And you know how, for example, x plus x is equal to 2x. Or, say, 1 plus 1 is equal to 2 times 1. If you just replace x, we could apply that same rule over here. So, That means angle ACD is equal to 2 times ACB. Why 2 times ACB? Because, in that same rule, x plus x equals 2x. If you replace x with ACB, that'll become angle ACB plus angle ACB equals 2 times angle ACB. This is a rule that, you must follow in equations. And, as you can see, angle ACB plus angle ACB will always equal to 2 times angle ACB. So, this is pretty much the answer. This is the formula for finding angle ACD. But, y'all have been asking, why did mom do this? Why did mom do this? Angle ACB equals angle ACD divided by 2. Why did mom do that? You see, as you can see here, it's just like some sort of example, actually. It's just, something. I don't know how to explain it, but just mom did it because she just did. There's no real reason. It's not necessary or anything. But what she did here, how she got this, is she divided both sides by 2. Why? No reason. You don't really have to do that, but you can. Well, if you're looking for, how to get angle ACB, then yeah, I guess it's necessary. So when we're doing this, we just cancel the 2 over here. That gives us angle ACD over 2 is equal to angle ACB. Or angle ACB is equal to angle ACD divided by 2. There you go. It's pretty much like 2 answers here. So